Hi everyone, welcome to chapter 11 of P2 P3 A levels on complex numbers. So a little bit of rationales why we need to study complex numbers. So previously when we look at the quadratic equation, for example x squared plus 1 equals to 0, we state that this particular quadratic equation does not have any solutions because when you write x squared equals to minus 1, it's not being defined. So in order for us to sort of like define a solution for this particular kind of quadratic equations, so basically we define a new number which is called the imaginary number, whereby the square of it is minus 1. So we will touch more about that later, so that we can sort of like define this particular set of quadratic equations to have a complex root or imaginary roots. So if you look at the set of numbers, for example, so we have the smaller set. Let's say this is the set of all natural numbers. So the set of natural numbers, you just have positive integers, but you don't have negative integers and you don't have zeros. When you include the zero inside, so you will have n0. So this is the set of all positive integers including zeros. Then a larger set will be the set of all integers, which is represented by the bold letter Z. And a bigger set will be the set of all rational numbers. And then a bigger than these rational numbers would be to include irrational numbers. Then you will have real numbers. So if we introduce this particular notation whereby x squared equals to minus 1, then we have a similar set which is called the set of imaginary numbers. So combining all these numbers together, we will have the set of complex numbers. So just a little bit of notation introduction. This will be the set of natural numbers so it doesn't include negative integers basically. And it does not include 0. Then if you want to include the 0 inside, so this will be the set of natural numbers including 0. So then the next set which is bigger than n0 will be Z, which is the set of all integers. So this set of all integers does not include fractions. That's why the next set which is bigger than Z will be the Q, because this will be the set of all rational numbers. So rational numbers are numbers that can be represented by fractions, but this does not include irrational numbers. So what are irrational numbers? So for example, e or pi, those are irrational numbers. Then the next thing would be r. This will be the set of all real numbers. So this set will include rational numbers, irrational numbers, and so on. But it doesn't include imaginary numbers. So imaginary numbers will be given by I. So now let's look at imaginary numbers. So this is written by I. By definition, imaginary number is some numbers, then when you square it, it gives you -1. So when you square it, it gives you -1. In other words, your imaginary number is the square root of -1. So then, with this particular definition, initially x squared plus 1 equals to 0. We previously learned that we don't have solutions. Now we can define it in a clearer manner. So we can say that this has no solution in the set of real numbers. But if you define what is called the imaginary numbers, then you will have so x squared equals to -1. So when you square root it, you will get plus or minus square root of -1 or plus or minus I. So this gives you two solutions in the set of imaginary numbers. Okay. So for example, if you have square root of -144, you can write this as square root of 144 multiplied with square root of -1. So in the end, you would get 12i. So a second example would be, you have, let's say, 9i minus I square root 2 power 3. So you just perform the algebraic manipulation as usual. So you get 9i minus I cubed, and then you have square root 2 power 3. So you can simplify this. So this will be I minus, multiply with I square, and then over here you have 2 square root 2. So in the end, this will becomes -1. So then you will have 9 plus 2 square root 2 I after you simplify everything. So now, if let's say you are asked to solve a quadratic equation, which previously you know that there is no solution, like for example 12x squared plus 3 equals to 0. So you know that x squared equals to -1/4. So when you perform the square root, as usual, please remember your plus and minus sign. And then you are square rooting the -1/4. So you can separate out the -1 multiplied with 1/4 to get plus or minus half I. So that's how you manipulate your imaginary numbers. So when you combine your real part of your numbers and the imaginary part of your numbers, you will get what we call as the complex numbers. So which is z equals to x plus iy. So this is coming from the real part. This is coming from the imaginary part. So as you can see, complex number actually covers the real numbers and the imaginary numbers. So usually notation wise, we write the real part of z will be x. The imaginary part of z will be y. So there are a few properties for complex numbers. The first one. So, sorry, before that, let me state that z1 equals to x plus iy. z2 equals to a plus bi. So I will use this particular notation for the rest of the discussion. So the first property, if you want to say that z1 equals to z2, what does it mean? It means that the real part has to be the same, the imaginary part has to be the same. So it means that x has to be equals to a, y has to be equals to b. So when you say that two complex numbers are the same, then you must compare the real parts and the imaginary parts. Second property is the idea of complex conjugate. So complex conjugate usually is denoted by z star. So let's say I want to do it on z1. It's either denoted by z1 star or z1 bar. The idea is that so z1 is equals to x plus iy. So basically now you are inverting the imaginary part to becomes minus iy. So that's the idea of complex conjugate. Why do you need to do this? We will see later on when we talk about multiplications. So now let's talk about addition. If you have z1 plus z2, so basically you have x plus iy plus a plus bi. So you sum the real part together and then the imaginary part together. So you get x plus a plus y plus bi. So this is how you perform addition. Subtraction is the same thing. So you have z1 minus z2. So you have x plus iy minus a. So because the minus sign should cover the whole complex numbers, so I put a bracket. So by right you should get x minus a plus y minus bi. So you add or subtract element wise. So now let's look at multiplication. For multiplication, let's look at z1 multiplied with z2. So you have x plus iy multiplied with a plus bi. So you multiply as usual, x multiplied with a and then x multiplied with bi. Just multiply as usual. So in the end you would get xa plus xbi plus yai plus ybi squared. I squared equals to minus 1. So in the end you would get xa minus yb plus xb plus ya. Okay, so that's how you perform multiplication. So now let's look at the previous example. Z1 For example, multiply with z1 conjugate. What do you get? So you have x plus iy multiply with x minus iy. After the multiplication, you will have x squared minus xyi plus xyi minus y square I square. I square equals to minus 1. In the end, you will get x squared plus y squared. So the reason why you would have complex conjugate is so that when you multiply with the original complex number, you will get back a real number. That's the reason why you need complex conjugate. So finally, let's look at division. Let's say you have z1 divided by z2. So z1 is x plus iy, z2 is a plus bi. So you don't really want your denominator to be a complex number. So usually what you would do is to multiply the top at the bottom with the complex conjugate of your denominator, which is a minus bi in this case. So once you perform the multiplication, so on top you will multiply x plus iy with a minus bi. So at the bottom we already see what will happen. This is basically a square plus b squared. So then you just perform the multiplication as usual. So you have ax minus bxi plus ayi minus byi square divided by a square plus b square. So in the end you will have ax plus by. So because I square is minus 1, so this becomes plus ay minus bx multiplied with I. Then the whole thing you divide by a square plus b squared. So that's how you perform addition, subtraction, multiplication, and division for complex numbers. And one additional property is the complex conjugates. So now let's look at some examples. So if you are required to find the quadratic equation that have the roots alpha equals to 1 plus 5i, beta equals to 1 minus 5i. So what will be that? So recall that when you have two roots, alpha and beta, you would form z minus alpha and z minus beta from your quadratic equation. So you multiply back together, you have z squared minus alpha plus beta z, and then plus alpha beta equals to 0. So now it will be easy for you to substitute inside what is alpha and what is beta. So z squared minus alpha plus beta, you find that this is equals to 2z plus alpha beta. And you notice that beta is actually the conjugate of alpha. So if you perform the multiplication, you know that this will be equals to 1 plus 5 squared, which is 25. So therefore, your quadratic equation will be z squared minus 2z plus 26 equals to 0. So let's look at the second example. Find the complex number u given that u multiplied with 3 minus 5i equals to 13 plus I. So you can let u equals to x plus iy, and then you multiply together, and then you make use of the first property, which states that when two complex numbers are equal, you must compare the real part and compare the imaginary part. So x plus iy multiplied with 3 minus 5i equals to 13 plus I. So you multiply them together, you get 3x minus 5xi plus 3y I plus 5y equals to 13 plus I. So you group the real part together and then the imaginary part together. So you have 3x plus 5y. So this is a real part. The imaginary part is 3y minus 5xi. This is equals to 13 plus I. So now you compare the real parts and the imaginary parts. So 3x plus 5y equals to 13. This will be your first equation. Second equation, 3y minus 5x equals to 1. This will be your second equation. So to solve this, the easiest way is to multiply the first equation with 3, multiply with the second equation with 5. So then the first equation will be transformed into 9x plus 15y equals to 39. Second one will be 15y minus 25x equals to 5. So now you minus them together to eliminate 15y. So you have 34x equals to 34. So it means that your x equals to 1. Then basically you can take, for example, from the first equation, 3 plus 5y equals to 13. So then 5y equals to 10, or y equals to 2. Finally, you can write u equals to 1 plus 2i. So we'll end this part for now. Tomorrow we'll continue with complex plane and the polar form and so on. See you.